Welcome back to another episode with tracking the coronavirus. It's been quite a while, but here we are with April 24th data. It is really, really, really early or really, really, really late. It's like 4 in the morning. But I was just experimenting with Google Sheets. I'm glad to show you what I found out. So here we are with some data. So we have a worldometer telling us that April 23rd, 2.723 million cases. So let's just update our info really quickly. So we have it for yesterday, April 22nd. Let's go. So 2,723,044. Perfect. Just verify that again. Okay. Yeah, and then we can just drag this down. Notch. Okay. So here we are, 87,000 new cases. That's a huge bump. And so if you notice, this is number of cases versus day. This is the same graph I've been showing you for all my videos. This graph no longer holds an exponential curve. This is now more of a logarithmic curve. In fact, I've set it to start at day, I believe around 70, 80, around there. So if you go to setup, you can now see that it says B80 to C130. So if we travel here really quickly, the 80th row holds data for day 100 actually. So April 8th, that was near the beginning of this month. And notice that I've still kept this infection rate to start with our day 23. But I think that for the time being, we should make sure that the number of cases versus day graph is no longer exponential. If we were to do that, it's really hard to track. So for example, if I gave you the data right here, if I just set it back to 3, I think it was 3, we enter that, and we delete this, you can see, kind of exponential, and then it curves off. And there's really no graph to kind of justify or kind of match a regression along the data we're looking for. So I think the best thing to do is just treat this as two different functions. The first interval being an exponential function, and then the second being logarithmic. And so now we're grabbing part 2 of the data, which is really good because that means we've passed the peak. But now we can get more accurate results with the logarithmic. And if we were to do exponential, this would look really, really weird. Let's see here. Let's make this exponential. Yeah, I mean, it doesn't really look like it's going at the exponential rate anymore. You can even see it in the rates. This thing is lingering around 3, so and then it's going down from 4, 3, and then maybe even like next week 2. So the rate is just going down, which means that it's no longer holding a constant rate. A constant rate would mean an exponential trend. But a rate that is not constant, rather going down, would mean more logarithmic, I'd say. So to accurately graph this data, we must get rid of part 1. By part 1, I mean from like day 0 to day 100. So I'm now just grabbing 100 to now. That portion of the graph, that's our domain, from 100 to now. And currently, we are on April 23rd, we got 115. We can call it 115. We don't have 116 yet. But we do have 115, and currently we're on day 115. So that's just off of 15 days of data. I don't know if that'll tell us much, but I know I have another graph that looks at the derivative. So first of all, I just want to kind of look at this. Let's see if we can create a whiteboard here. Okay, so here I have a whiteboard. You can kind of full screen this. Let's wait for it to load. Okay, perfect. Let's do this with a black pencil. Whoa. All right, so the super black pencil. So here we are. This is what total cases are going to look like. This is total. In fact, I can kind of write with my finger. Advantages of a touch screen. Total cases. Oh my gosh. I need to work on my handwriting. All right, total cases. So what do we call this function? We call this right here. We call this a logistic model. Now, what is a derivative? A derivative is essentially a slope. So a slope is basically a rise over run. Let's just look at this graph and see what we can get. So here we can see mostly a flat line, right? There. You can also see a flat line here. And those are our zero slope lines. We might see kind of like a near vertical line here. And then the slope will become less and less, getting to zero. And here the slope increases, the rise over run increases, right, to a vertical. So you can kind of see that shift. And if we were to graph this shift in slope, we would call that our derivative function. So let's say, let's say we're to clear this. Let's say we went back with our logistic model, right? Can extend this actually. And we were to graph the slope function. So the slope here, and we'll call this actually use a different color. This is our y-axis, and this is our x-axis. And in blue, we'll do our derivative. So the slope for the majority of this part is 0. So we're just going to draw some dots at 0. Now we're going to assume that this slope is like around 1. That's 1. We can assume this slope is around 2. We can assume this slope is around 4. And this slope is 8. And then here, well, this slope now is back to 4. You can see this slope and this slope being the exact same. So now, instead of graphing here, we're going to graph here, back to 4. And this slope is 2, and graph here. And this slope is 1, going to graph here. And this is 0, and graph back here. And then for the majority of the part, it'll be 0. So, if we look at that trend, okay, whoops, we don't want that. Let's get rid of our ruler. So redraw that with our y and x axis. Pretty sure I used red, but whatever. This, we use red now, is our derivative function. You can see that our original logistic function looked a little bit like this. And you can see that this is super high because the slope at this point was the largest slope. So that's what a derivative is. It's just the gathering of data sets within the domain of all the slopes at each point. And notice the x-axis lines up perfectly. For instance, here it has a lesser slope. Here it has near 0 slope. So it will kind of match that. Of course, this graph is off, but that's as best as my finger can get with the touchscreen. But we'll clear this canvas for now. The main point was to show you guys that we have a derivative function. And what we can do with the derivative function is better predict. So we call this a bell curve graph. And the previous graph was, the original function, was a logistic graph. So how can we kind of predict this? Well, a lot of 4x to the 4, this is a quartic function. We'll call this a quartic function. Can actually show us this data. We go back here to our graph. I've developed this to show you this is our derivative function. We can make this a lot smaller to fit our screen size. Let's make that a lot smaller. Okay. Let's see if we can go any further. Okay. Okay, so you can see here, this is the blue. It's the actual data. And these are the new cases per day. That's our derivative function. New cases per day. Every time we increase in our daily count, we hold that as our slope. That's our derivative. And like I said, our original is logistic. Well, this is actually a bell curve. The derivative is a bell curve. So if we were to graph this, we could model it around a quartic function. And our quartic function yields that on day 125, you can see right here, on day 125, our cases would have gone to, or our increment of cases, in other words, our new cases, would have gone near 0. So day 125, that is around here, May 3rd. So that is our safe bet. However, May 3rd is in like 2 weeks, and I highly doubt that the world is going to end coronavirus in 2 weeks. So quartic functions might be off, but I've heard that Google spreadsheets can do better modeling with bell curves. I'm still looking into that, so keep tuned for more content. I might just come up with a way to model a bell curve. But again, modeling a logistic function is really hard. So it's best to just think about a logistic function as 2 parts. Where's my laser? Okay. Yeah. Okay. So this part, which is exponential, and this part, which is logarithmic. This right here is day 100, or April 8th. We have passed that. We are now on day 115. All right, yeah, we're on day 115 now. So we'll see how this thing goes. Hopefully we can bring the slope down to 0, and hopefully we can see the number of cases decline to 0, and we can see that everyone is doing much better. There's been good news that more vaccines are being spread out. A lot of good drugs like remdesivir is kind of being researched to treat the coronavirus. I'm not 100% sure of anything right now. No one is really, but a lot of good tests are being done, and hopefully in a month we could kind of come up with something to strengthen our position on the coronavirus. Again, this is global, so just disclaimer there. And I highly doubt this thing is going to go away in 2 weeks, not even 2 months maybe, which is quite scary. Again, if we were to look at those graphs again, this is our trend of new cases per day, and it looks like it's kind of staying at around between 80 to 100,000 cases per day, which is huge. Compared to a percentage, it looks really small here. It looks like 3%. It looks like nothing, but it's going up by 100,000 cases per day, which is huge. And if we look at the interval it took to get to that, it took 75 days. So it might take 75 more days, resulting in day 175, which is the end of June. Yeah, that could be it. The end of June, this thing is gone. So no one really knows. Again, I promise to track this every day. I haven't been keeping up with that promise, but I will update very frequently. I can assure you that. And I will let you know about new trends, new graphs, new data. Please stay in touch. Please subscribe. Hit that like button. And please comment below if you have any feedback from me. I'd appreciate that very much. Thank you for watching. I'll see you guys in the next one. Take care. Bye.